This is the first test to see how this is gonna kind of go. So basically, I want to do my schoolwork, university work, right? But I don't really want to do it. So I was thinking if I try and record it, it might make me be able to do it more. So I'm not really sure how it's gonna work, but we're gonna go with the flow and we'll refine it later. Trial through what's that word? Through trial and error. That's the one. Anyhow, we're doing computer logic, basically the Zhao stuff. I'll be mostly referring to myself in this. So it's the Zhao stuff. We're gonna see if we can even understand it. We might not even get it at all. All right. So computer technology and maths, controlling, routing, and storing memory. By the way, I'm kind of lost on all of this. So within a computer, data is communicated from sources to destinations via paths via electrical wiring. Well, kind of already know that. Data can move from multiple sources to a single source by using a multiplexer concept. I'm assuming this is a multiplexer concept. So inside CPU, data to be manipulated is stored using assemblies, registers, or fast one bit memories. I'm not really sure what those words mean. So why don't we use ChatGPT actually to help us with this? You see this ChatGPT and the notes? It's got to help us. So let's go to ChatGPT right here. And in computer logic, also the funny thing is, right, if I watch this later when I already know this stuff, it's going to be like so painful for me to watch. What in computer logic, what is, oh crap, come on, what is data to be, okay, let's just put that in, data to be manipulated is stored using assemblies, or fast 1-bit memories. Fast 1-bit. So you're like, why don't I just put the whole slides in ChatGPT? I kind of did that, but I want to actually go through the slides, In computer data like numbers is stored in memory elements that CPU can access quickly. These memory elements are often implemented as registers or flip-flops, which are 1-bit storage unit. Each bit stores either a 0 or 1. So there's elements, right, and they have a 0 or 1. Assemblies, the term assembly is not typical for storing individual bits. It refers to an assembly language or module assembly. The fast 1-bit memories are like flip-flops and registers. Or data to be emulated in computer logic. Okay, that low-key doesn't help that much, but it's fine. We'll just move on. Last term, we saw how logic operate and what they could do. Now we'll use that to make them do something useful. Right. The ID number of device to switch all of the switches of control. It sends 1 to devices to turn on, and 0 to devices to switch off. Okay, so 1 to turn on and 0 to turn off. And this thing must be the decoder inside the physical computer. Is that not pointing to the same thing? Or maybe it's talking about something else. The binary decoder. Translate a binary number with an ID code into a binary number with a single 1. Okay, not sure what that means. Decoder, a circuit that translates or decodes coded information from one format to another. It's just, decodes it basically. A binary decode transform n binary signal inputs into an equivalent code using 2 n outputs. Okay. Yeah, not making any sense so far. Decoder, a circuit that translates or decodes coded information from one format into another. Binary decoder transforms n. Okay, I have no idea. Maybe it'll make sense later. Okay, this is a decoder, a circuit that translates or decodes coded information from one format into another. So we have it in one format, and then this logic map kind of thing, shape here, turns it into another format. I'm assuming it's like inputs from the user into like the format of something the computer can understand, like binary, something like that, along the lines of, or that type of thing, not exactly that. A binary decoder transform n binary input signals into an equivalent code using 2 n outputs. Alright, if you say so. A decoder is a circuit that translates or decodes code information from one format. That literally it's just the exact same thing. Oh, it's just a decoder. Wait, what? Is it not the exact same thing? Oh no, that's a 2 to 4 decoder. This is a 3 to 8 decoder with an enable. Okay, I'm pretty sure the enable, it's like a switch. It has to be on for the other ones to be able to do anything. And when it's off, the outputs can't change. But when you turn the enable on, then you can change your inputs, and then the output can change. I'm pretty sure, fairly sure. Okay, it's the same words again. Is it 4 to 16 line decode implemented with 2 3 to 8 decoders? Okay, so we have 2 of these top ones here, the blue box, 2 of them, and it's called a 4 to 16 one. Interesting. The decoder, for example, let's take a look at the 4 to 1 multiplexer from lab 1. The binary decoder can be used to control. We can use a 2 to 4 decoder to control the ANDs and thereby route the desired input to the output. Okay, hold on. So this is a 2 to 4 decoder. And we can control it, all the 3 straight drivers. We have 4 inputs, A, B, and C. Then we have control A, B, and C. And so if we have input A, B, or C is true, we also need to verify the control to make it true. And then if any one of them is true, then it will be true at the end. That's what it's looking like here. Because the AND, obviously, and you need both inputs. And control A goes to input A. And all the same for the rest. And then there's one big OR at the end for all of them. So that kind of makes sense. That's just a decoder then, eh? Okay. Another one here. It's just saying the exact same words. So we've got A and B, which inverts it. And then, okay, there's a lot of lines here. Small a goes to the AND with big A and small b. And A also goes to the third AND with, I have no idea, with lowercase b, but not with a not. And then A, but it's before it's been inverted, goes to the last one as well. I'm unsure what this does. And then B goes to that, C goes to that, D goes to that. And then they've all got A or B. So A's got A. So capital A has got lowercase a inverted and inverted B. And then B's got inverted B and... wait, 1, 2... I can't... and lowercase b? These lines are genuinely hard to see. Oh, lowercase a. Oh my goodness. You know what? I'm going to stop looking at that. Bringing it all together. Oh, right. This is all of them, apparently, then. Interesting. Bringing it all together. In CLR, generally, you should use named connections to make correlations. In summary, the bottom keypad allows data to be entered. Okay, so this thing in the corner, just above where it says clock, the red thing on the left, and the bottom thing there, I can't point to it. That you put your data in. All registers clock together. Load enable controls where the data goes in. What is the enable then? Not exactly sure. Can move data from any register or keypad. So I'm assuming those 3, the little spider things there, are the registers, because they have buses going to. Well, they all have buses. Move data from any register or keypad to any other register in the clock cycle. So from the keypad which you enter in first, you can move it to any other register, I think. The top keypad controls the top 2 bits for the bottom source of the destination. Okay, that's a bit confusing right there. Anyhow. Large number of memory cells in a single device. Use same control bits for output and input. The control bits referred to as address. May also connect input and output together. Allows direct connection to a bus. Okay. Memory cells are atomic circuits that store small chunks of information. When connected together into a spatial arrangement, they form addressable components of larger memory. No clue what that means. Also, I'm just thinking, right, what is the point of this? What, I will never watch this again because this is boring as hell to me right now. So I don't even need to know this later. Like, if it's not going to be tested, I don't even need to know this. I'll either have much higher knowledge of this is like, be basic, or I just won't need to know at all. I have no idea what is the point of recording it, but I'm going to do it anyway, honestly. I need at least one. Let's see what happens. Anyway, let's at least finish these slides. How long is it? Okay, we're nearly at the end, 22 hours, 55. Okay, address select rows and columns that remove cell of interest. 2D grid addressable memory, that's a lot of them. This layout is not meant to be fully representative of memory circuit. It is broadly similar to static RAM. Input and output often together. It will be connected to a bus, KKK, OK, memory components, and CDAL logic. several sides, organizations available, see help. That's it. Decoders are a simple way of controlling or enabling parts of a circuit. Decoders are multiplexers from the backbone for controlling and memories and grid arrangement of memory cells. Okay. Don't know if you got any of that. It only took me 10 minutes. But we have gone through one slide now, you know?